Russian scientists have determined the design of the future first lunar nuclear power plant, which has been named Selena. At the same time, the Americans are actively working on their own nuclear power plant project. How do our approaches differ? And why is it so important to win the new lunar race, even though everyone has plenty of problems on Earth? We'll talk about this after a brief summary of technological news. The new multifunctional emergency rescue icebreaker ship Kerch Strait has joined the Marine Rescue Fleet. The first new power unit of the Kursk Nuclear Power Plant 2 with a VVEE-RTOI reactor has been connected to Russia's unified power system. The Vostochny Cosmodrome has been connected to the largest substation in the Far East, Amurskaya, thus receiving a second source of power supply. The first Russian large-capacity liquefied natural gas carrier, liquefied natural gas Alexei Kosygin, has set off on its maiden voyage along the Northern Sea Route to work as part of the Arctic Liquefied Natural Gas. 2 project flight tests have begun for the light single-engine multi-purpose helicopter Mi-34M1 with the newest VK-650V engine. The largest Russian CubeSat, Scorpion, in the 16-unit format, has been successfully launched into orbit and brought under control. Scientists from the Russian Quantum Center have presented the first ion quantum computer based on QDITS, a quantum system operating with 7 quantum state levels at once. The domestic laser counter-drone system has, for the first time, hit and first-person view drone at a distance of 1 kilometer during testing. At the National Research Center Kurchatov Institute, the design of the future lunar nuclear power plant, named Selena, has been determined. Details about the project are not being disclosed, but it is known that it is based on the technologies of the low-power nuclear power plant, Elena AEM, which is being developed specifically for the harsh conditions of the Arctic. And in turn, it is known that this is a compact nuclear power plant with a capacity of up to 5 megawatts, whose main feature is the ability to operate autonomously. The station does not require permanent personnel. After the reactor is connected, it operates for decades, supplying nearby settlements with electricity and heat. Essentially, it is a high-capacity nuclear battery with a service life of 40 years. Electricity is generated by thermoelectric converters, which means there is no turbine or complex mechanisms in the design, allowing it to operate autonomously without shutdowns for maintenance. However, such simplicity and autonomy come at the cost of low power and a low efficiency that does not exceed 10%. But the Northern Yelena AEM is not meant to replace large nuclear power plants, but will be used where it is more practical and faster to install such an unpretentious nuclear battery than to build a classic station with several power units. This same principle is at the core of its space sister, Selena: maximum simplicity and autonomy. However, lunar conditions impose additional limitations. Although Yelena is considered a compact nuclear power plant, when assembled it is still a 15-meter cylinder weighing 168 tons. Currently, humanity does not have rockets capable of delivering this payload to the moon. In addition, it is impossible to use water as a coolant on the moon, and there are many other limitations. That is why a new project had to be developed, Selena, where instead of water, a liquid metal coolant is used, and the weight of the entire installation without protective structures does not exceed 1,100 kilograms. The reactor will be installed on the lunar surface and covered from above with a multi-layer dome made from local regolith and Kevlar, which will protect it from micrometeorites and extreme temperature fluctuations. Yes, the electric power output due to the chosen reactor type will be only 10 kilowatts. However, at the initial stage, this is quite sufficient to supply a small research station in combination with solar panels. In the future, according to the concept project of the Moscow State University of Civil Engineering University, it is planned to add new reactors and combine them into a single, more powerful system. Thus, the Russian approach to building the first nuclear power plant on the moon involves simplicity, high deployment speed, and autonomy. The Americans, however, have taken a different path. The Americans proceed from the idea that they immediately need a powerful source of electricity with high efficiency on the moon. That's why they chose to create a 100 kilowatt installation using dynamic energy conversion with a turbine and a complex heat removal system. The reactor, weighing 5 to 7 tons, should fit into the cargo bay of a rocket like the SpaceX Falcon Heavy. The nuclear power plant's design is modular. The core, turbine, and radiators are delivered separately, and assembly takes place on the moon. If the Russian Selena will operate on a set-it-and-forget-it principle, the American station will require regular maintenance of the turbo machinery and the high-temperature circuit. This is the price for higher power. Also, despite the higher efficiency, the Americans will have to consume and therefore deliver to the moon more nuclear fuel, and as a result, they will generate more nuclear waste. Both the Russian and American projects are complex and expensive, since a nuclear power plant on the moon must also have an extensive infrastructure of power consumers. In our case, this is a small research base, while the Americans immediately aimed for a larger scale construction, which apparently includes the placement of the first production facilities. Neither we nor they can do this alone, so Russia is working within the framework of the International Lunar Research Station program, which includes China and a number of friendly countries, while the United States is working within its Artemis program, which also includes dozens of countries, mainly from the Western world. Our base is scheduled to be put into operation in 2035. This may seem like an overly optimistic forecast, but the Americans take it very seriously, so they are accelerating their program to install the first nuclear power plant on the moon as early as 2030. Of course, it's hard to believe this, and it's likely that neither we nor they will meet the stated deadlines. The world's leading powers are clearly determined to explore the moon, and it will happen eventually. But why? Why are countries in such a hurry in spending resources on a new lunar race when each of them already has plenty of problems here on Earth? "500 years ago, Spain and Portugal were drowning in urgent problems: an empty treasury, widespread poverty, uprisings, plague, endless wars, and religious conflicts. But despite all that, both monarchies made a risky and, to many, incomprehensible bet on distant sea expeditions, which soon marked the era of great geographical discoveries and transformed the world. Today, the leading powers are facing a similar crisis, which requires expansion beyond their usual environment to resolve. The moon is a new continent that will provide humanity with resources that are currently inaccessible, accelerate the emergence of new technologies, and once again, change the world. But the current stage of the race to build the first lunar nuclear power plant also has a more down-to-earth explanation. The thing is, according to international law, no country in the world can declare the moon or any part of it as its own property. However, the Americans found a loophole. If you place a hazardous facility like a nuclear power plant, you can legally designate the area around it as a protected zone, restricting access for other countries. And it seems permanently. After all, even after such a nuclear power plant reaches the end of its service life, its spent nuclear fuel will remain in place, which means that area will continue to be off limits to outsiders. In other words, the more stations a country builds, the larger the territory it will be able to claim for itself. And in this light, Russia's choice of the modular Selena project, even though it's not very powerful, but is quick to build, easy to manufacture, and scalable, takes on additional significance. After all, there aren't that many prime spots on the moon. In a sense, the most prestigious real estate today is the convenience spots on the moon. For now, they don't belong to anyone and cost nothing, and whoever gets there first will secure their rights. However, there aren't that many suitable locations, which explains the growing rivalry. One of the key parameters is having a flat area at least 10 by 10 kilometers in size. This is where spacecraft will land and where the base will be built. It's also important to have direct radio visibility to Earth to ensure communication. It's crucial for the site to be illuminated by the sun for as long as possible, which will allow solar panels to recharge and reduce the load on nuclear power plants. There should also be resources nearby. Regolith as a building material and lunar ice as a source of water. In addition, the terrain should allow for optimal routes for robots. The areas near the poles best meet these conditions. That's exactly where the Chinese, the Americans, we, and other countries want to establish themselves. And in some cases, the zones of interest overlap, which is why there's a rush. Whoever gets there first will secure their rights. Although Russia is participating in a joint project with China, we are also maintaining plans for independent exploration of the moon. We have thoroughly studied and selected suitable sites at both the South and North Poles. Despite the failure of the Luna 25 mission, we are preparing new ones. In 2028, the Luna 26 orbital spacecraft will be launched to provide communications, followed by other spacecraft, including a new lunar rover, so that we can later begin building our own national base. We will keep you updated on developments in future episodes. Next, the announcement. The Americans' capture of Maduro took many by surprise, as if there hadn't been similar forceful actions recently against Saddam Hussein, Muammar Gaddafi, Slobodan Milosevic, and other leaders. But why does Trump really need this? After all, he could have just continued to strangle Venezuela economically. Why take this risky and controversial action? The answer lies somewhere most people aren't looking. In 2024, the Chinese ceremoniously put into Operation Chancai, a deep-water megaport in Peru, capable of receiving the largest container ships in the world. And recently, a Chinese container ship, converted into a warship with concealed cruise missile launchers, was spotted docked in Shanghai. How are these events connected, along with the United States' claims on Greenland, and of course Russia's restrained reaction to what's happening in Latin America? I break it all down in my new video on my personal channel at sponsor.rusuper.
If you have overcome your fear and doubts, then your time has come. It's Russia's time, a time for achievements, a time to move forward.
This is the time, our time. We've been waiting for it for a long time.
Our time has come. Think, act, push forward. Forward, forward. There's no time for fear or doubt.